X is the current in amps as well. Sorry, I don't have a number for it. The energy at that point would be less than at the beginning. Correct. Yes. The potential decrease as you go down the street. I have one more demonstration to show you.
Okay, so this is our last demonstration. Here we have 3 light bulbs hooked up, what we'll call a parallel circuit. We have 3 different branches out of the power supply. We have a switch here with one cord that's going to break off the top of the circuit. It's going to go to the wire nut and break up into 3 separate paths and go through the 3 light bulbs. They're going to reconvene at the other wire nut, heading back into the power supply and then back to the power company. So this is our power supply. What's the power supply? What's the voltage out of the power supply? 120 volts. Very good. That's always going to be the same. And so now we look at our light bulbs here. We have 3 light bulbs in here. They're all 60-watt light bulbs. So we're going to take one and we're going to turn it on. Shield your eyes. Stay right here. So here's my one light bulb. Now, can I find the current through that light bulb? Good. Yes, it certainly can. We know that from yesterday, we know that the power in an object equals the current times the voltage. We said the power here is 60 watts, and we're going out from 120 volts in the outlet, and so that is what? 0.5 amps. Very good. And so we know that through that first light bulb, there is 0.5 coulombs every second passing through it. And so what you're getting out of the power supply over here from ComEd? 0.5 amps. Very good. And so we have this much, this is the speed of our charge. Now here's the question we'll ask. I'm going to now screw in the second light bulb. What's going to happen? So good. This bulb might get dimmer. And what does it mean if this bulb gets dimmer? Does that mean anything to me?
The current is slower.
Right, good. So if this bulb gets dimmer, we're going to equate brightness and dimness with the speed of the charges. And so if this bulb gets dimmer, that means the current became slower. If it gets brighter, that means the current got faster. If it stays the same brightness, that means the current didn't change at all. And so does anyone think this bulb will get brighter?
I do.
Oh no. Well, hopefully that won't happen. That'd be very odd if we had more current afterwards. And so some of you I know think it's going to get dimmer. Some of you think it's going to stay the same. And so that's what we're going to find out here. So let's see what happens. All right. So we see now that these bulbs both stay the same brightness. Good. And so if this was drawing half an amp before, what is this bulb drawing now? Oh, it's drawing half an amp. And so what that means to me, because we have 120 volts, each electron has to lose 120 volts. And so it's going to go from the bottom through this light bulb, lose 120 volts, and then go back to the power supply again. Electron up this branch will do the same thing. So each bulb still 120 volts. We each got half an amp. Is that a problem?
Yeah.
No, not at all. This is, now from the company, if these are each pulling in half a coulomb per second, what's the power company giving me? 1 coulomb per second. Very good. Did the power company mind?
No.
No, of course not. Why not?
They get more money.
More money, right. They want all that money. Energy companies are not very friendly. They want all the money they can get. So every time I plug another bulb in, I'm still using only 120 volts, because that's just establishing how big my mountain is across the light bulb. But now I'm pulling more and more the current faster from ComEd. From this bulb on now, each of these is now half an amp. So what's ComEd going to give me? 1.5 amps. Now there's 3 bulbs, half an amp each. So I have 1.5 coulombs every second. ComEd's going to give me as much power as I want, as fast as I want it, but they're going to charge me for it.
Is this what we did in class today?
Yeah. And trying